Hi guys. So today we're going to be talking about visual representations of real numbers. Please feel free to stop, pause, excuse me, rewind, fast forward. I'm sorry, I got hiccups over here at your own pace, okay? So just a quick overview of rational numbers. A rational number is any number that can be written as a fraction with the denominator of b not equal to 0. So some examples of rational numbers. We're going to start with the natural numbers. The natural numbers, which are counting numbers, 1, 2, 3, all the way up into infinity. Our whole numbers are all natural numbers, including the number 0, okay? So remember, whole numbers are the same thing as natural numbers. They just include the number 0. Integers. Integers are whole numbers and their opposites, meaning these are going to be positive and negative numbers. Whole numbers are only positive, natural numbers are only positive. Here, when we get to integers, we're going to integrate those negative numbers, okay? When we talk about our fractions, our repeating decimals, and our terminating decimals, those only fall under the subset of rational numbers only, okay? Integers cannot be a decimal or a fraction. Only rational numbers can. So when we have a repeating decimal that just repeats or has some type of pattern like this one does, those are going to be rational. If we have a terminating decimal, meaning that the decimal does stop, then that will also be rational. And then we have our perfect squares. Square root of 16, if you break that down, that just comes out to the whole number of 4. The square root of 100 comes out to 10, and the square root of 144 comes out to 12. So these are all rational numbers, okay? So what's new to 7th grade? GT honors. Irrational numbers, okay? Non-perfect squares. So if you take the square root of 5, you break that down, you're going to get some random decimal that does not convert into a fraction. You cannot make a ratio out of it. So it will not be a rational number. Same thing for all of the rest of them. If you break any of these numbers down, you'll have a long decimal that you cannot turn into a fraction. So therefore, they are irrational numbers. So no natural number times itself will give you the answers above. Non-repeating, non-terminating decimals, these numbers go on forever and never repeat, okay? And those will be irrational numbers. For instance, pi, 3.14. I know we usually just say 3.14 and we stop there, but that's because we're rounding it off. That number keeps going and going and going and it never ends, okay? That dot, 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 the dot, 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 you already know it means it's never ending. So let's look at some at a subset. So you have your natural numbers being the smallest one, and your natural numbers go into your whole numbers. Your whole numbers go into your integers, and then your integers go into the rational numbers. So the biggest set here is the rational numbers, okay? And it breaks down smaller and smaller and smaller. Or if you want to say it goes bigger and bigger and bigger, however you want to do it. Irrational numbers are completely separate from rational numbers. So let's look at some examples. Here are some rational numbers. If I do the square root of 49 and I get 7, I could put 7 over 1 and that can still be that's a perfect fraction. That makes that rational. Over here, I have 4 and I have 4 wholes and 1/5. If I say 5 times 4, I get 20 plus 1, I have 21 and I keep my denominator 21 over 5. That's a fraction. That is a rational number. Here, same thing. If I divided this by 10, this is what I would get. And here, we know if we have a little line over a number, we know that that's a continuous thing. And this is 2 over 3. So these are all rational numbers. Here's an irrational number. I know y'all probably can't see this for some reason. I'm sorry that it's looking like that. But these numbers keep going on and on and on. They do not repeat. And they do not end. So these numbers are all going to be irrational numbers. Here's some more examples for you. And let's try it. Take some time to try these. And if you have any questions about what these are, please just message me. Okay? Bye, guys.